Hi guys, welcome back. I'm going to talk to you about force distance curves. Force distance curves are going to be a way for us to express the force that something is applied over a certain distance, and we'll be able from this to calculate both work and energy. So work and energy are going to be the areas under the curve of this. If you have a spring, and it's an ideal spring, you can get the spring constant from the slope of a graph like this, which we saw when we derived potential energy of a spring. In AP, sometimes they make this a little sloppy. If it's sloppy, like this example here, where it's a curve, you can estimate this to be a triangle on top of a rectangle and find those two areas. Or if you have the function, you can take the integral of what that line is if you have calculus. I'm just going to do one example with you guys because there's not a lot of examples of these problems in AP. So it says a student uses a spring scale to exert a horizontal force on a block, pulling the block over a smooth floor. The student repeats the procedure several times, each time pulling the block from rest through a distance of 1 meter. So the distances are all the same. For which of the following graphs of force as a function of distance will the block be moving the fastest at the end of the 1 meters? So it's a smooth floor. That tells me there's no friction. So all of the work that I'm doing is going to turn into kinetic energy. And so I'm looking at which one has the biggest area. Looking at the top one, it has an area of 3 times 1, which is 3. B has that same big rectangle, but it has a smaller rectangle on top of it, so B is bigger than A. C is a triangle, which I see could fit underneath the B one, so B is definitely bigger than C. And then D has the same big rectangle. D has the same big rectangle as B, and an additional triangle, which is going to be smaller than what this rectangle is. So my choice is going to be B.